Sir Isaac Newton is the best known for his work on gravity, but he worked on discovering many other scientific wonders during his lifetime. Besides his work, the universal gravitation, known as gravity, Newton developed the three laws of motion: law of inertia, law of acceleration, and also law of interaction, which form the basic principle of modern physics. Newton's first law of motion described the behavior of massive body and rest of in uniform linear motion, not accelerating or rotating. The first law states a body at rest will remain at rest, and the body motion will remain in motion unless it acted upon by an external force. This simply means ang mga bagay hindi kayang gumalaw, tumigil o magbago ng direction. All by themselves, it requires some force acting on them from outside to cause such change. For example, meron akong papanood sa inyo, pag na-hit ng auto yung auto, it will change its direction and then will stop because there's another force to stop it. So, panoorin nyo.
The law of inertia states that objects will maintain their state of motion unless acted on by an outside force. This means that moving objects will stay moving and still objects will stay still, unless you push or pull on them. There are two safety devices in your car to protect you from the effects of inertia. The first is your seat belt. When the front end of your car rams another object, your car will suddenly stop or slow down. Because of inertia, your body will want to stay moving at whatever speed it was moving before the accident. If you're not wearing a seat belt, this means you will hit a windshield. The seat belt provides a force to stop your body's forward motion. The second safety device in your car is a headrest. When your car is hit from behind, the car is suddenly pushed forward. Your head will want to stay still, but your body will be pushed forward by the seat. This causes your head to feel like it is snapping back. Your head is actually staying still because of inertia, while the rest of your body is being pushed. Your headrest pushes your head forward with your body so that you don't suffer from whiplash. Look at the difference between a headrest that is properly set versus one that is set too low to push your still head forward.
Let's move to the second law of motion, which is the law of acceleration. Let's go.
When we are in a stationary car that moves rapidly to gain speed, we get pushed back against our seat. And when brakes are applied, we get pushed ahead. Or when we take a sharp right turn, we're pushed towards the left. These are all situations where we are accelerating. We have all experienced this, whether in a car or a bus or while riding a motorbike. Simply put, when velocity changes, we have acceleration. I still haven't defined what acceleration is. I just told you that when velocity changes, there will be acceleration. Okay, let me give you two examples. In the first one, a car is traveling in a straight line at a constant speed of 80 kilometers an hour. And in the second one, a plane is traveling in a straight line at a constant speed of 1000 kilometers an hour. In which case do you think acceleration is involved? None. In both cases, the velocity is not changing at all. Hence, there will be no acceleration in either of the cases. Most people relate acceleration to high speed, and that's clearly not true. Acceleration will only exist when there is change in velocity. Do you remember what velocity is? It's speed with direction, and it's hence a vector quantity. Why is this important? Let's say a body moves from rest and reaches a velocity of 20 kilometers an hour in 5 seconds. Will acceleration be involved here? Yes, because the velocity is changing. It was 0 initially, and at the end of 5 seconds, it's 20 kilometers per hour. In another scenario, assume that a body is moving at 30 kilometers an hour and then it moves right at 30 kilometers an hour and continues traveling at the same speed of 30 kilometers per hour. Will there be acceleration in this case? The answer is yes. As the direction is changing, the velocity will also change. The only thing constant in this example is speed, but the velocity changes as the direction changes. So this was the most important concept you had to know about acceleration. It will exist only when there is a change in velocity. But how is acceleration calculated? Acceleration is defined as the rate of change of velocity. In terms of a formula, acceleration can be written as change in velocity over the time taken. If the velocity of an object changes from an initial value of u to the final value of v in time t, then the acceleration a can be written as v minus u over t. Say this object is at rest initially at point A. It then travels to the right and attains a velocity of 10 meters per second in 5 seconds. What will be the acceleration here at point B? We can look at the formula to get the answer. The initial velocity u is 0 meters per second as the object is stationary. The final velocity v is 10 meters per second and the time taken t is 5 seconds. Hence, the acceleration a will equal 10 meters per second minus 0 meters per second divided by 5 seconds. So this will equal 10 meters per second divided by 5 seconds. 10 divided by 5 is 2. Wait, hold on. What will be the units of acceleration? We should get a hint by looking at this. The units of acceleration will be meters per second, because it's the change in velocity over the time taken. As this is meters per second, we can carry this second to the denominator and what we will get is meters per second squared. This one is more intuitive, but this one is a bit neater, I would say. So the acceleration in this case will be 2 meters per second squared. And acceleration is also a vector quantity. Here, acceleration and velocity are in the same direction. There are many more important concepts about acceleration which we will cover in the coming videos.
According to Newton's second law of motion, a force upon an object causes it to accelerate. According to formula net force, mass x acceleration, there are 3 components to Newton's second law. First, a force on an object will cause it to accelerate. Second, this acceleration is directly proportional to the force. It means third, this acceleration is inversely proportional to the mass. And the third law of motion, which is the law of interaction.
Ow! For the first scene, why it is so hard for us to push a heavy object? How about in the second scene? Why is it so painful to punch a wall? Just like in the movies. And today, we're gonna explain that through the third law of motion, named law of interaction. What is law of interaction? Law of interaction states that for every action, there is an equal but opposite reaction. Let's take this for example. I am holding a laptop. I am actually exerting an upward force on this, while the laptop is exerting a downward force on me or on my hand. For example, I am exerting 2 newtons having an upward direction, while the laptop is actually exerting 2 Newton, but it is downward. That is law of interaction. For every action, there is an equal but opposite reaction. Let's have these examples. In this picture, the action is the tires push on the road. And the reaction, the road pushes on tires. How about this one? In this picture, the man pulls on spring. What's the reaction? The reaction is the spring pulls the man. And that is law of interaction. Just always remember that to every action, there is always an equal but opposite reaction. See you again in my next vlog, and I hope you learned today. Bye-bye! Thanks for watching. Please don't forget to like, share, and subscribe.
The law of interaction is also known the third law of motion, stating that each action brings an equal and opposite reaction. Forces either pushes or pull resulting from the interaction between two objects. Some interactions come from contact, while others come from force and act over distance, such as magnetism and electricity or gravity. For every action, there is an equal opposite reaction. This statement means that every interaction, there is a pair of force acting on two interacting objects. The size of the force on the first object equals the size of the force on the second object.